A robot so tiny it can travel through tight spaces in the human body and perform surgical functions wirelessly. Scientists at NTU Singapore have developed a robot about the size of a seed. It can enter the body and move, cut tissue, deliver drugs, collect samples, and generate heat for potential cancer treatment. Is this future of minimally invasive surgery? We speak to researchers for more. We have Associate Professor Zhan and Nicholas Foo joining us now. Welcome both to the show. Well, let's start with Prof. Lam here. How does such a tiny robot cut tissue, deliver drugs, and even treat cancer?
So one of our major goals in doing this kind of small-scale robots, right, is that one day we can actually inject them into the body, navigate them to a targeted location, and perform treatments. The way that we are going to control the robot is through magnetic fields. By using magnetic fields, right, we can actually allow them to move, right, and by controlling its magnitude, directions, and the spatial gradients, we are able to allow it to produce specific functions. What is the key thing here that allows it to have 5 functions is that we can actually remagnetize and demagnetize a specific part of its body. By using this strategy, right, we can effectively expand its functionalities and perform all the surgical functions that you have just mentioned.
Yeah, so that's quite amazing. We have Nicholas in the studio here with us now, and you've also brought the robot with you.
Yes, I have.
So it's the size of a seed. Can you show it to us?
Yes.
So our viewers can also have a look at it. Can you explain how it's being used?
Okay, sure. So you can have a look at the robot over here. And this is the size of a typical robot that we use here. And we usually use, for most of our robots, magnetic fields to control them, because these magnetic fields are very safe for use with humans. And we can power them wirelessly. And this can enable them to be controlled when they are inside the human body and perform the various tasks that they are set out to do. So we can do the 5 functions that you mentioned to deliver drugs, cut tissues, store, manipulate, and as well as remote heating for hyperthermal therapy.
So far, all the tests that have been conducted are with chicken liver or even tissue-like material. So how safe is it for use in the human body?
Oh, that's a very great question. So we have done a lot of testing with simulated tissues, such as the chicken liver, but we have also done some tests which would help check on the biocompatibility of these robots. And our tests show that they can be used safely with these live tissues. And these biocompatible tests are actually done out in the clinical studies for use with humans, and they ensure that it can be safely used inside the human body. And we're also using very safe materials, such as silicons, which have been used in the literature for humans.
Yeah, so Prof. Lam, I want to bring you in again. Since the robot is controlled wirelessly, how can doctors then track and also navigate it inside the body? You mentioned the magnetism. That was one force that you were using.
Right. Thank you for the nice question. Yes, we're using magnetic fields to control the motion and function of the robot, but we can also use medical imaging techniques such as ultrasound, X-ray or CT scan, or even perhaps MRI to actually visualize and localize the robot. By using the combination of magnetic fields and this kind of medical imaging techniques, it is possible to actually allow the surgeon to effectively control this kind of robots when they are navigating inside the human body.
Yeah. So we also talk about how this tiny robot can then generate heat to help with cancer treatment. So how is this different from other current techniques that are being used that can also do this with precision and safety?
Right. So definitely this kind of heat treatments are very critical for cancer treatments, and we are already using some of those kind of treatments in clinics now, right, for real treatments, right? But if we are using small scale robots, right, we can potentially increase the efficacy of this kind of treatments. The reason is because all these robots, they can move to very specific locations and provide very localized heating. By doing so, right, we will only kill the cancer cells that we need to destroy, and we will ensure that the healthy cells will not be put out too. So what we are trying to say here is that this kind of technology can significantly enhance future heat treatments for cancer.
Yeah. So
It
Nicholas,
has the
looking at
potential to do so.
how small this robot is in person as well, once you've put this robot into the human body, how do you get it out? So for people who are a bit concerned.
I understand the concern. So if you can see our robot, it's actually endowed with tiny little legs. So like a human, it's able to walk and it can even roll around. And using its locomotion, the way it can enter the body after it's been injected in, or we can swallow it, it can crawl to the point of entry, through the entry to the targeted location, perform the things it needs to do, and it can then use its dexterous little legs to walk itself out back through the same way it came in.
Yeah, so and all this is of course controlled by the doctors outside in the application as well.
Yes, so the doctors will have the full autonomy to control it, but we also hope to be able to, in the future, incorporate machine learning techniques and some AI to help us more dexterously control it and to actually help the surgeons to have make it more simpler for them to control it and more intuitive.
Wow. So, Prof. Lam, before we go, what are the kind of surgeries then that you feel can be very quickly applied to this technology?
Right. So although the possibilities are very wide, right? We can start with something simpler. That means to start with surgical procedures that are more on the surface or more superficial. That means closer to the skin, right? So some of the treatments that we can look at would be, treatments for the eye, the ear, in the nose, right? Then in the future, we can actually go beyond that, right? We can go for treatments inside the digestive system, right? And perhaps in the very long run, right, we hope to do surgical processes for the brain and also for the heart and many other kind of organs. But of course, that is a very a long-term goal. Right? The short-term goal will be those that are more superficial, nearer to the skin.
Yeah, very exciting applications ahead. We look forward to that as well. Well, Prof. Lam and Nicholas, thank you both for joining us today and sharing about this micro robot. Associate Professor Lam Guo Zhan and Nicholas Foo from the School of Mechanical and Aerospace Engineering at NTU.